Welcome to Trinod chemistry classes. In this video, I am going to discuss about intermediate first year chemistry topic, atomic structure in EAPCET, NEET and JEE mains point of view. In this atomic structure topic, I am going to discuss about Bohr's atomic model. What are the postulates of Bohr's atomic model, and then based on the postulates, Bohr has derived formulas, some formulas to calculate the radius, energy, and so on. So, what are those formulas will be discussed. Thank you for watching Trinath chemistry classes. Please like the video, share, and subscribe the channel. To overcome the objections of Rutherford's model, to overcome the objections or limitations in the Rutherford's model, and to explain the hydrogen spectrum or fine structure or Zeeman effect and Stark effect and all these things, to explain this, Bohr proposed a model which is known as Bohr's atomic model. So according to this Bohr's atomic model, electrons are revolving around the nucleus in circular orbits. The electrons are revolving around the nucleus in circular orbits. And the energy of these orbits, we are calling it as the stationary orbits. And these are designated as KLM and so on, or denoted by 1, 2, 3, 4 and so on. 1, 2, 3, 4 and so on. So the electrons are revolving around the nucleus in circular orbits. This is the first postulate. And the second one is, these orbits are called stationary orbits and are designated as KLM and so on, or denoted by 1, 2, 3, 4 and so on. And the energy of the orbit means the energy doesn't change with time. That's why these are called stationary orbits. And angular momentum of electron is quantized. Angular momentum of electron is quantized. And is an integral multiple of quantized and integral multiple of h by 2 pi. So MVR is equal to NH by 2 pi. MVR is equal to NH by 2 pi. So when electron jumps from one orbit to another orbit, energy either may be evolved or absorbed. So these are the important postulates of the Bohr's atomic model. So in video lo manam ee Bohr's atomic model nu upyoginchi, Bohr's atomic model nu basis cheskuni, he has derived some expressions to calculate the energy and radius and so on. So ఆ ఎక్స్ప్రెషన్స్ ఏంటి అన్నటువంటిది ప్రధానంగా వాటి మీద బిట్స్ వస్తున్నాయి. ప్రధానంగా ఈ వీడియోలో మనం ఆ ఎక్స్ప్రెషన్స్ ఏంటి, డెరివేషన్స్ చూడట్లేదు, ఓన్లీ ఆ ఎక్స్ప్రెషన్స్ ఏంటి అన్నది చూడబోతున్నాం. So to calculate the radius of the orbit, so Rn is equal to n square h square by n square h square by 4 pi square m into 4 pi square m into k into z. So this is the expression for the radius of the nth orbit, where n is the principal quantum number. For example, if it is first orbit, n is equal to 1, second orbit, n is equal to 2, h is the Planck's constant, m is the mass of the electron, k is a constant, z is the atomic number, e is the charge of the electron. So this is the expression for the radius of the orbit. This is the expression for the radius of the Bohr's orbit. So if we substitute h is equal to 6.25 into 10 to the power of minus 34 joule second. This is Planck's constant. Similarly, M value, K value, and E value, we will get an expression. So, and pi value also, if we will get an expression 0.529 into m square by z times 10. Right? So here, if we substitute H is equal to 6.625 into 10 to the power of minus 34 joule second, and mass of the electron is 9.1 into 10 to the power of 31 kg, and K is the E is equal to 1.602 into 10 to the power of minus 19 coulombs, and K is equal to 9.9 into 10 to the power of 10. So if we substitute all these values and if we calculate, we will get expression like this. Rn is equal to 0.529 into m square by z angstrom units. Angstrom units. Right? This is the expression for the Bohr's radius, to calculate the Bohr's orbit's radius. For example, if n is equal to 1 for hydrogen atom, z is equal to 1, R1 is equal to 0.529 angstrom. N is equal to 2, z is equal to 1 for hydrogen atom, R2 is equal to 0.529 into 4 by 1. So this is becoming right. So like this, we will get an expression, angstrom units, 0.529. 36, 3, 8, 11, 1, 1, 100. So 2.11 angstrom. So these are the expressions for the hydrogen atom. For hydrogen atom, z is equal to 1. సో దీని మీద మనకి ఆబ్జెక్టివ్ లో బిట్స్ ఎలా వస్తాయి అన్నది తర్వాత డిస్కస్ చేయడం జరుగుతుంది. సో దిస్ ఇస్ ద ఎక్స్ప్రెషన్ ఫర్ ది బోర్స్ ఆర్బిట్. సో Rn is equal to n square h square by 4 pi square m into k into z into e square. So if we substitute the values, these values, we will get a general expression. Rn is equal to 0.529 into n square by z. N square by z. So this is the expression for the radius of the Bohr's orbit for hydrogen-like species. Now, then second one is for energy. So total energy is given by kinetic energy plus potential energy. Kinetic energy plus potential energy. So here for kinetic energy, the expression is, what is the expression is K into ZE square by R. K into ZE square by 2. Similarly, for potential energy, expression is minus K into ZE square by R. Right? So if the total energy expression is given by kinetic energy plus potential energy, ZE square by 2R minus K into ZE square by R. So we will get an expression of minus K into ZE square by 2R. ZE square by 2R. So the total energy expression is this one, minus K into ZE square by 2R. So we know that for radius of the orbit, what is the expression? N square H square by 4 pi square m K into ZE square. So if we substitute this expression, so the energy expression we will get N is equal to En is equal to minus 2 pi square K square into Z, K square into Z square into e power 4 pi n square is. So this is the expression for the energy of the Bohr's orbit. So what is the expression for the energy of the Bohr's orbit? Minus 2 pi square Z square K square e power 4 m by m square is. So this is the expression for the energy of the Bohr's orbit. So he has derived expression for the kinetic energy, similarly for potential energy, and the total energy is given by kinetic energy plus potential energy. This is the expression. So we know that radius of Bohr's orbit is given by Rn is equal to this value. So I am substituting this value and I am getting En is equal to minus 2 pi square z square k square into m e power 4 by n square is square. ఇందాకట్లాగే మనం కూడా ఇప్పుడు ఇక్కడ పై వాల్యూ, కే వాల్యూ, ఈ వాల్యూ, ఎం వాల్యూ, హెచ్ వాల్యూ సబ్స్టిట్యూట్ చేసి సింప్లిఫై చేస్తే కనుకండి మనకి ఈ వాల్యూ ఎంత వస్తుంది అంటే కనుకండి మైనస్ 2.21.79 into 10 to the power of minus 90 by n square into z square into z square. So this is joule per atom. This is the unit for the joule per. So this is the expression for the or in terms of joule per atom, right? So minus 21.79 into 10 to the power of minus 19 z square by n square joule per atom. Joule per atom. So this is the energy expression for the Bohr's orbit. So in other units, if we take En is equal to minus 13.6 by minus 13.6 into n square by z square electron volt per atom. In terms of electron volt. In terms of electron volt. Right? So please remember 1 joule is equal to 6.2419 into 10 to the power of 18 electron volts. Similarly, 1 electron volt is equal to 1 electron volt is equal to 23.06 kilocalories. 1 electron volt is equal to 23.6 kilocalories per mole. Right? So this is in terms of joule per atom. This is for electron volt per atom. Then if we write in terms of kilocalories, minus 31.36 into n square by z square. Kilocalories per mole. Then in terms of En is equal to minus 1312 into n square by z square. Sorry. N square into z square by n square. Z square by n square. This is in terms of kilojoule per. So these are the energy expressions for various in various units. అంటే డిఫరెంట్ యూనిట్స్ లో ఇది జౌల్ పర్ ఆటమ్ అయితే ఇది ఎలక్ట్రాన్ వోల్ట్ పర్ ఆటమ్, ఇది కిలో క్యాలరీస్ పర్ మోల్, కిలో జౌల్ పర్ మోల్. సో ఇప్పుడు ఇక్కడే కెనెటిక్ ఎనర్జీ తీసుకున్నాం అనుకోండి ఒకసారి. కెనెటిక్ ఎనర్జీ ఈజ్ ఈక్వల్ టు ఇన్ టర్మ్స్ ఆఫ్ minus 13.6 into z square by n square. This is the kinetic energy expression. Electron volt per atom. ఇదే పొటెన్షియల్ ఎనర్జీ తీసుకుంటే కనుక minus 13.6 into z square by minus 13.6 sorry 27.2 into n square electron volt per atom. So here kinetic energy is equal to minus of 2 into sorry potential energy is equal to minus of 2 into kinetic energy. Minus of 2 into kinetic energy. So these are the expressions for the various energy of the to calculate the energy of the electron present in the various Bohr's orbits. So దీని మీద ప్రాబ్లమ్స్ ఎలా వస్తాయి అన్నది మనం వెరీ సూన్ నెక్స్ట్ వీడియోలో చూస్తాం. సో ఈ ఫార్ములాస్ అన్ని మనకి ఆబ్జెక్టివ్ పాయింట్ ఆఫ్ వ్యూలో వీ హ్యావ్ టు రిమెంబర్. నెక్స్ట్ దిస్ ఈస్ ద ఎక్స్ప్రెషన్ ఫర్ ది ఎనర్జీ. Now, for velocity of the electron in present in the Bohr's orbit is given by V is equal to Z by N into V is equal to Z by N into 2.188 into 10 to the power of 8 centimeters per second. Centimeters per second. Centimeters per second. So this is the energy expression for the velocity of the electron which is present in the nth orbit. Which is present in the nth orbit. So this is the expression. Right? So Vn is equal to. Vn is equal to. Right? So for example, if n is equal to 1, and for hydrogen like that, for hydrogen atom, n is equal to, then what is the V1 is equal to 2.188 into 10 to the power of 8 centimeters per second. For example, for V2, so here for 1 by 2 into 2.188 into 10 to the power of 8 centimeters per second. So if we solve 1.094 into 10 to the power of 8 centimeters per second. Right? So these are the expressions. Similarly, for V3, 1 by 3. So మనకి ఆబ్జెక్టివ్ పాయింట్ ఆఫ్ వ్యూలో ప్రాబ్లమ్స్ ఎలా వస్తాయి అన్నది we will see in the next video. So for time being, please note down the formulas. Right? So ఇది మనకి మూడోది ఎక్స్ప్రెషన్. నెక్స్ట్ థర్డ్ వన్ తీసుకుంటే కనుక ఒకటి రేడియస్ చూసాం, రెండు ఎనర్జీకి ఎక్స్ప్రెషన్స్ చూసాం, మూడోది వచ్చేసరికి వెలాసిటీకి చూసాం, అండ్ నాలుగోది వచ్చేసరికి ఏంటంటే కనుకండి ఆర్బిటాల్ ఫ్రీక్వెన్సీ. ఏంటంటే ఆర్బిటాల్ ఫ్రీక్వెన్సీ. ఏంటి ఆర్బిటాల్ ఫ్రీక్వెన్సీ ఏంటి? ఆర్బిటాల్ ఫ్రీక్వెన్సీ అంటే కనుకండి నెంబర్ ఆఫ్ రెవల్యూషన్స్ per second. Number of revolutions per second. Number of revolutions per second by an electron. By an electron in a shell is called orbital frequency. Is called orbital frequency. So దీనికి ఎక్స్ప్రెషన్ ఏంటంటే కనుకండి ఆర్బిటాల్ ఫ్రీక్వెన్సీకి ఎక్స్ప్రెషన్ ఏంటంటే కనుకండి z² by n² into 6.66 into 10 to the power of 50. So this is an expression for the orbital frequency. Orbital frequency. Right? So for orbital frequency, this is an expression. Sorry, not n², this is n³. z² into n³ by 6.66 into 10 to the power of 15. 10 to the power of 50. So this is an expression for the orbital frequency. Orbital frequency. And the last one is time period. So the expression for the time period, Tn is equal to n³ by z². n³ by z² into 1.5 into 10 to the power of minus 16 seconds. 10 to the power of minus 16 seconds. So this is an expression for the time period. So మనకి ఈ ఆబ్జెక్టివ్ పాయింట్ ఆఫ్ వ్యూలో తీసుకుంటే కనుక వీటి మీద ప్రాబ్లమ్స్ వస్తాయి. ఎలాగ వస్తున్నాయి, ఒక ఫ్యూ ఎగ్జాంపుల్స్ ఏంటన్నది నెక్స్ట్ వీడియోలో నేను డిస్కస్ చేస్తాను. ప్లీజ్ నోట్ డౌన్ ద ఫార్ములాస్. ఇది ఇంపార్టెంట్ టాపిక్ మనకి, వెరీ పర్టికులర్గా EAPCET కానీ నీట్ పాయింట్ ఆఫ్ వ్యూ, JEE మెయిన్స్ పాయింట్ ఆఫ్ వ్యూలో వీటి మీద మనకి న్యూమరికల్స్ అడగడానికి అవకాశం ఉంది. థ్యాంక్ యూ ఫర్ వాచింగ్ త్రినాథ్ కెమిస్ట్రీ క్లాసెస్. ప్లీజ్ లైక్ ద వీడియో, share and subscribe the channel.